Okay, look at that picture there. That's something that's called a surface of revolution. What they've done is they've taken this red function that you see there, okay, and then they spun that function around the x-axis. And it traced out that blue shape, which is kind of like an urn or a vase sitting on its side. Okay, I want to show you how to calculate the area of that. Do you remember when we were talking about integrals and we said if you want to find, oh, did I say area? Sorry, I meant volume. I want to show you how to find the volume of that shape. So do you remember when we were talking about integrals? And we said if you wanted to find the area under a curve, the trick was to stack a whole bunch of rectangles inside, right? And then shrink the width of the rectangles down to 0. And then add up their areas, right? Okay, same idea is going to happen here, except the only difference is we're going to stack a whole bunch of disks inside. You see, like this one right here? And this one here. And there's one here on the edge. Now, what's the area of each disk? Let's just look at the biggest one. Is a circle, and the area is pi times the radius squared. What's the radius of that disk? I'll draw it for you. There it is. How long is that radius? Doesn't that go from 0 up to a height of f of x? So isn't the radius equal to f of x? So the area of that disk is pi times f of x squared. Correct? Now just imagine stacking that urn full of infinitely many disks. And if we integrate the area of the disks, pi times f of x squared, which if you prefer you can write it like that, with respect to x, from A to B, that will give us the volume of the urn. Okay? So let's just do a practice problem. Okay, look at that question. Find the volume of the surface created by rotating the area bounded by y equals 4 minus x squared and y equals 0 around the x-axis. Okay, let's start by graphing. I mean, you don't have to do the graph to answer this question, but it might be easier. So here is y equals 4 minus x squared. You should at least know that that's an upside down parabola from pre-calculus, okay? And here is y equals 0. Okay? So they want us to take this area and rotate it around the x-axis. Okay? I won't try to draw it because I'm not very good at it. But it'll look more or less something like that, except instead of looking like an urn, it'll look like just a parabolic circular thing. Okay, let me ask you a question. Where does this, whoops, that's not what I wanted to do. Where does that start and where does it end? Okay, well, it starts at -2 and it ends at +2. So based upon the formula above, the volume would equal the integral of, so what's my f of x in this case? That's the top boundary. So that would be this. So that's the parabola, 4 minus x squared. So I would integrate pi times, hang on, there's a u that showed up in the middle of our picture. Let's get rid of that. There we go. All right, so I would integrate pi times 4 minus x squared from -2 to 2. All right, this is going to be a pretty straightforward integral. The pi is a constant. Let's take that out front. 4 minus x squared is 16 minus 8x squared minus x to the 4th, plus x to the 4th, integrating from -2 to 2. So that's going to give us pi times 16x minus 8/3 x cubed plus 1/5 x to the 5th, x going from -2 to 2. So that will be pi times, now let's just plug in 2, and this is calculator work here, so I'm just going to do this on my computer and tell you what we get. So it's 16 times 2 minus 8/3 times 2 cubed is 8 plus 1/5 times 2 to the 5th is 32. Okay, so that comes out to equal 256 over 15. Okay, minus. And then plug in -2. And you're going to get -256 over 15. And so our final answer is 512/15 times pi. That's our answer. And if they gave us units, then this would be cubic units because it's volume. Okay? Let's do one more. You probably know that the volume of a sphere is 4/3 pi r cubed. Let's show why that's the correct formula. Just one second here, I'm having trouble. Okay, so a sphere is simply a semicircle rotated around the x-axis. Okay, so imagine that sphere right there with a radius of r. So that sphere is really just a semicircle rotated around the x-axis. What is the equation of that semicircle? Okay, well, you probably remember we get x squared plus y squared equals r squared, right? Which would mean y squared equals r squared minus x squared, which means that y is plus or minus square root of r squared minus x squared. Now, we're looking at the top semicircle. The y values are positive, so we can throw away that minus. Okay, so we have y equals the square root of r squared minus x squared. On the x-axis, that spans from negative r to positive r. So let's find the volume. We would integrate pi times the square root of r squared minus x squared squared from negative r to positive r. So that's pi times the integral of r squared minus x squared with respect to x. So r is not a variable here, it's a number. Okay, so what would that give us? That would give us pi times r squared x minus 1/3 x cubed, x going from negative r to r. So that would be pi times, so plug in r. Do you see that you'll get r cubed minus 1/3 r cubed? So that would be 2/3 r cubed, and then minus, and now plug in negative r, and we'll get negative 2/3 r cubed. And so our final answer will be pi times what? 4/3 r cubed. That's where that formula comes from. Okay, that's all for today. Pretty short lecture, I know, but it's just that only that one concept that I think we need to cover.